All right, so this is a video to help you with the final quizzes. If you have any things you need help with, you can watch it first or watch it later. It's not really an exam, but we'll use it for review later on too. Okay, here we go. So all the topics that are on are covered. There's a video notes link at the bottom of each one if you need more help. First of all is Sig Figs. So I'm just going to first say how many Sig Figs there are in each of these. There's 4, 5, 3. So for this rule for Sig Figs, you go left to right. The first non-zero digit is a Sig Fig, and then anything after the decimal point that's a number is a Sig Fig. If they chose to write it, if it's a 0, this one's 3 Sig Figs because the number after it is a 0 and there's no decimal point that you can see. If it would have been 30, 50 point with a decimal point showing, it would have been 4. Okay, so round this to 2 Sig Figs. You look at the next digit, it'd be 0.12. 4 Sig Figs, 1, 2, 3, 4. So I'm looking to round it to 2. That 9 bumps up to a 10, which makes that 2 become a 3. 3 Sig Figs, 1, 2, 3. There's my third Sig Fig. Look to the right, 415. That's the most often used is 3 Sig Figs. 2 Sig Figs. I look at the second digit, it's a 0. To the right of that's a 5, so this becomes 3100. Skew. With the histogram, they're going to ask you about skew. They might ask you about totals. You can just add the totals. If you make a little curve, wherever the gap is stretched, that's the skew. So this is to the right, sometimes called a right-handed or positive. To the left, negative. Means there's small values that are away from the mode. And here, this is symmetric. So this is general one variable stats. Put all the data in your calculator into a stat list. Do one variable stats. Hit enter. So I have my one variable stat. So find the mean and standard deviation. There's the mean. 32.3 to 3 sig figs. Standard deviation, we use sigma. 8.86. The other one is called sample standard deviation. Find the range and the interquartile range. Those are measures of dispersion. So the range, you take the minimum and the maximum and subtract them. So 45 minus 2, the range is 43. Interquartile range, you subtract the 2 quartiles, 39 minus 27, that is 12. Check. Write down the median. You can write it down from there. Lower quartile is called Q1, upper quartile is called Q3. Smallest in value, they just basically gave you the 5-number summary. It says check whether there are any outliers. Outliers, you take 1.5 times the interquartile range. So that is 18. And you take the lower quartile, which is 27, minus 18, which is 9. The upper quartile, which is 39, plus 18, and that is 57. Anything outside of those values would be an outlier. When you look at your list, the lowest is 20, the biggest is 45. Everything is fine. Last one, draw box and whisker data. All the values you find in C, you're going to do that, come up with the scale. This data goes from 20 to 45. So I'm just going to pick a scale to go by 5s here. Make a point at the smallest. I'll make an X. Point at the largest. Make a point at the median. Make a point at the lower quartile, upper quartile. The box goes around the quartiles, and you extend the whisker to the end. 25% of the data is in each quartile. The lower quartile is the median of the bottom half. The upper quartile is the median of the top half. however many values you have, there would be that many in each one. This one has got an odd number, so it's split a little bit. Cumulative frequency graph. A couple things right off the bat. This looks like there are about 360 values in our list. This side, we always have symmetry. This bottom axis, we don't. To find the median, I would need to go to 180, roughly right there, over and down. So 1100 is in the middle. I would say the median is about 1050. Lower quartile, if that was 180, I would go to 90 because that's half of 180. Roughly 700. Q1. Upper quartile is the 75th percentile, so I could take 75% of 360. Or if I know I had 180 here, half of that's 90, that's take me to 270. So right at 1200 would be the upper quartile. So if they told me the minimum and the maximum value, I could make chart. Notice there's symmetry here, but not over here. These are not necessarily symmetric. If you had to find a percentile, let's say what percentile of the values fell below 600, there's 600. You go up and over, it's about 80. So you would take 80 out of 360, change that to a percent. We're going fast. We're going fast. Okay, this is a chi-squared test. Just to review the steps, these are the observed frequencies. Sometimes there's a total there. Sometimes you can find the total if you need to. So I'm going to find the totals of each row and column. So that's 50, 34, 46. Over here, 70 and 60. So that means there should be 130 values. I can add that one easily. I want to make sure. Yep, 130, 130. Okay, show that the expected number of rabbits who eat carrots first. So rabbits and carrots first is right here. Show that's 26.9. I would take the row total, which is 70, times the column total, which is 50, and divide it by 130. And that would be 26.9. Show the expected number of hamsters who eat lettuce first is 21.2, row total 46, or sorry, column total 46, row total 60, and again I divide by 130, and that would be 21.2. Find the chi-squared value. The way you do that is your calculator. You enter the values into a matrix. Make sure it matches this. Don't include totals. Go to stat tests, go down to chi-squared test. Make sure it says A, whatever you put them in is the observed, B is the expected. Run the test. It gives you a chi-squared value of 8.05. If they gave you a value from a table, a critical value, you could make a decision. If the critical value, if the chi-squared is greater than the critical value, we reject. Usually we also can compare that to P. So let's say we're testing this at a 5% value. If P is less than 0.05, we reject the null hypothesis. So it is, we would reject it. We would say that lettuce, or what they eat first, is independent of what type of animal we have. That would be the null hypothesis. Would be lettuce or carrots or whatever you want to call it, their food they eat first is independent of the type of animal. So we would reject, so therefore we would say what they eat first is not independent of the type of animal. Pearson's R, hopefully you know this one. Enter data in list 1 and list 2. Make sure your diagnostics are on. Do stat, tests, or calculate, linear regression. You get these numbers. The R value tells you strong positive correlation. That means the values are close together, increasing. There is a line of regression here. Y equals mx plus b. There's my m. 5.55. There's my b. 36.9. So you can use it to predict. They said, what if you took 6 papers, x equals 6, what would your examination grade be? You'd take 5.55 times 6 plus 36.9. You do not use the value on the table, and you get a number. They said, if I scored a 97 on the test, what would the number of papers be? That means y is 97. And I'm going to solve this little simple two-step equation by subtracting and dividing whatever you get there by 5.55, and that would use my line. Anything that is outside of the range of these values, so anything bigger than 12, smaller than 1, I don't know how you have smaller than 1, I guess 0. And from on here, anything outside of 96 and lower than 43 would be called extrapolation, and it makes the data not reliable. Anything in between is called interpolation. Inter means between. So I have strong positive correlation. So if I stay in that range, then my data is reliable. Spearman's rank. We rank the coefficients from highest to lowest. So the first one's pretty easy because they go in order. The second one starts out easy. 1, 2, 3, 4, and then we have a tie. And so these are 5, 6, and 7 sharing that space. So 5 plus 6 plus 7 divided by 3, they all get 6s. Put it in your calculator, do the same thing you did with linear regression and run it, and you get an R, negative 0.964. That means the data is getting smaller. If you got an R of -1, it would have been monotonic. That means it's strictly decreasing. If you look at the original data graph, it is strictly decreasing until it hits here, and then it is consistent. It would have to keep going down to get an R of -1. T-test, most recent thing we did. She's interested if the mean height of male students is the mean height of female students. So you can call this X bar or a mean, either way. So state the null hypothesis. Mu1 is equal to mu2. We always assume they're equal. State the alternative. If you want to use x1, you can't. The x you can, but since they tell you it's mu, I'd say use that. Calculate the p-value for the test. Put these each in a list. They don't have to be the same length. Go to 2 sample t-tests on your stat tests. Make sure you select data. Have your 2 correct lists. Then you got to decide on the alternative hypothesis. On this one, they're just asking you to see if they're different. So we're just seeing if they're different. Make sure you have pooled selected as yes. Hit calculate. And we're looking at 2 values. One is the t. If they ask it, they didn't ask it. They said find the p-value. So 0.296. State or other reason why they should accept. So we got to look and find the significance level. If 0.296 is less than 0.1, we reject. So it is not true. So we would accept the null hypothesis. That's all the processes that are on that quiz and that we've done. If you fast review, there's a video link at the bottom of each one. You download this and open the link.